2.5 is on graphing linear inequalities in two variables. So we're going to have basically solid or dotted lines with shading above or below. Okay, so a linear inequality is going to look like kind of like y equals mx plus b, but instead of an equal sign, you're going to have greater than, less than, greater than or equal to, less than or equal to. Okay, it's represented by a line with shading on one side. To find where to shade an inequality, you're going to pick any point not on the line and see if the inequality is true. So plug in any point off of the line and see if the inequality is true. So if you got like 0 is less than 4 in the end, then we'd be like, oh, 0 is less than 4, so that point that I plugged in is going to be part of my solution set. So I would shade it. The boundary line is dotted if we have greater than or less than, and the boundary line is solid if we have greater than or equal to or less than or equal to. So basically the equal to part is just filling in the line. It's shading that line as well. So the first one, so I have y is greater than x plus 5. So your boundary line is just if we had y equals x plus 5. And will that boundary line, will it be solid or will it be dotted? Dotted, because it just says greater than, it doesn't say greater than or equal to. Equal to would fill in the line. So this is going to be dotted. All right, so we are going to graph the line y equals x plus 5. So we know that that has a y-intercept of 5. So I go up 1, 2, 3, 4, 5. And then it has a slope of 1. So we go up 1, right 1, up 1, right 1, up 1, right 1. Or you could go down 1, left 1 as well. So my slope is positive, so I just make sure that it's going upwards in the end, right? And then you take a ruler, and we would draw a nice dotted line. This is the part that every Algebra 2 student will mess up, and then you guys take your eraser and you erase, erase, erase. All right, now we pick any point that's off of the line. What's the point that's easiest always? Do you guys remember this? 0, 0. So is the origin, it's not on the line. Do you guys see? It's not even anywhere close to the line. That's good. Sorry, the rooster has been going crazy lately. All right, so, yeah, I know. My YouTube videos are probably like, I talk about the rooster all the time. They're like, what? Why does she have a rooster outside of her classroom? But I do. I have a rooster outside of my classroom. All right, so 0 is greater than 5. Is that true or is it false? It is false. 0 is not bigger than 5. So we do not shade this. This cannot be part of our final solution. So we're going to shade away from that. So I shade up here. Now there is a trick. If you have actually, like if you have an equation that's in the form y is greater than, y is less than, whatever, mx plus b, when it says greater, then you're going to go above the line. Okay, so I know right away, like without plugging in a point, that I'm going to shade above the line. So that is a quick trick that you can do, okay? But this next one, when it says 2x minus 3y is less than 6, I don't know that it's going to be below the line because of this, because I haven't solved for y. Does that make sense? So you have to have it in the form y equals mx plus b if you're going to do that. All right, so I said on this one, it might be useful to use the intercept method. So let's see if you guys remember the intercept method. So our boundary line is 2x minus 3y equals 6. So if I'm finding the x-intercept of that line, I plug in 0 for the y value. So if you remember, when I plug in 0 for the y value, I cover up my y value with my finger, right? So I'm going to cover that part up. So if I cover that up, I get 2x equals 6. If 2x is equal to 6, what's my x value? 3. And same for the y-intercept. So take your finger and cover up the x part now. So when you cover up the x part, you get negative 3y equals 6. So what do we get? 0, negative 2, exactly. So we have 3, 0, and 0, negative 2. Our line is going to be a dotted line because we didn't have an equal. Equal means fill in the line. So we're going to do a nice dotted line. So now I have to decide if it's above or below. And I said I can't just look at it and be like, oh, it says less than, it's going to be below, because it's not solved for y. So this is the case. If you don't solve it for y, you have to plug in a point. So see how 0, 0 is still off the line? So 0, 0 is right here. So that's a good point to pick. So when I pick 0, 0, I get 0 minus 0 is less than 6, so 0 is less than 6. So I'm plugging back into this original. So 0 is less than 6 is true. So that means 0, 0 is a solution. It's something that makes this true. So I shade towards my 0, 0. So I'm going to shade above in this case. Some of you guys get a little shading crazy. All right, you learn not to get shading crazy once you do the wrong side, and then you have to erase all of that shading. So just lightly shade. You could use a color pencil lightly if you want to. Probably don't use a marker. All right, is this making sense? Are you guys feeling pretty good about this section? Yeah, good. All right, so what if I have y is greater than or equal to 6? So remind me, what does y equals 6 look like? Does it look like straight up and down, or does it look right to left, horizontal or vertical? This is a horizontal line, right? So if I have y equals 6, that's a horizontal line. Because I want to have every single point that has a y value of 6. So I'm going to have 0, 6, 1, 6, 2, 6, 3, 6. I'm going to have all those points in my line. And in this case, we have a solid line because it says greater than or equal to. So you could still pick a point. You can pick 0, 0 and plug it in. You get 0 is greater than or equal to 6. That's false. Or you can just say, oh, wait, I want all y values that are bigger than 6. Well, would that be above or below the line? It'd be above the line, right? Every single point that has a y value that's bigger than 6 is above that line. All right, so if you have something like number 4, you can solve for y if you want to. Or you can at least get rid of that 3/4. So if I'm going to get rid of the 3/4, what do I multiply by on both sides? Yeah, 4/3, the reciprocal, right? So I'm going to multiply by 4 over 3. And this doesn't flip my inequality sign or anything. I didn't multiply by a negative. But if I did multiply by a negative, I'd have to flip it, right? Red flag rule. So I'm going to get 8x minus 2y is less than or equal to, this is 24 over 3, which is 8. And then you can just do the x-intercept, y-intercept method. So it's kind of in that standard or general form again, right? So if you want to do x-intercept, y-intercept, you can do that. If you didn't, then you can always solve for y. So let me show you what this would be if I solve for y. So I would subtract my 8x over. So I'd have negative 2y is less than or equal to negative 8x plus 8. And then we divide by negative 2. So that's what I was saying was the red flag rule, as I call it. We divided by a negative, so we have to flip our sign. So instead of having less than or equal to, we're going to flip it to greater than or equal to. So we get y is greater than or equal to negative 8 divided by negative 2 is positive 4, so positive 4x. 8 divided by negative 2 is negative 4. So that negative 2 goes into both parts of the numerator. All right. And then you can graph. It's in the form y equals mx plus b, so we know our y-intercept is negative 4, that's the b, and our slope is 4. So our slope, if it's 4, it's up 4, right 1, right? Up 4, right 1. So I'm going to go up 4, right 1, up 4, right 1, up 4, right 1, and so on. Will this be a dotted or a solid line? It's a solid line, right? So we draw that in. This one's kind of close to 0, 0. So if you weren't sure if your line's a little bit wobbly, you can always pick something else. But I'm going to go ahead and pick 0, 0. And you can plug it into the original. So I have 3/4. 0 minus 0 is less than or equal to 6. So 3/4 times 0 is still 0. 0 is less than or equal to 6. So that is true, right? 0 is less than or equal to 6. So we shade towards the 0, 0. All right, still feeling pretty good about this? So you guys probably did these types of questions in Algebra 1. Okay, so there can be like story problems, or there can be other things that have shading involved. Like you could have a parabola that has shading around it, right? So we'll talk about those later in Algebra 2. I think today we're going to do an absolute value function as well. All right, so do you guys want to try number 5 and see if you can get number 5? So try it on your own first. All right, so go ahead and try it, see what you get. Fun. Okay, so first of all, is it dotted or solid? Solid, because it's less than or equal to. So we're going to multiply both sides of the inequality by negative 5 over 6. And that's going to clear that first fraction for us. Okay, and when we do that, that's the red flag rule. We have to change it. We have to change our sign because we multiply by a negative. So I'm going to have 10x minus 15y. And then, ooh, that's kind of tricky because I have that plus 3. I could have made this easier on myself. I could have subtracted 3 to begin with. Should I do that first? Yeah. Let's do that. Did you guys all recognize that? I didn't see it sneaking in there. So I subtract the 3. So I'm going to have my negative 6/5. All of that is less than or equal to 0. So when you multiply by negative 5/6, that's when you're flipping the sign. So now you're going to have greater than or equal to, and it's still 0. So I get 10x minus 15y like that. Is that why you guys were asking back there? You still flipped it? Okay, yeah, because it's still 0. All right, and then we can find our x and y intercepts, but what's wrong with this one?
0, 0.
Yeah, both of them are 0, right? It goes through the origin, 0, 0. So when that happens, I would just go ahead and solve for y, okay, because it's now going through this point, 0, 0. So let's do another step. Let's subtract the 10x over, and then divide by negative 15, which flips our sign. Lots of flipping here going on. So I get 10 over 15. What's 10 over 15 make? Yeah, 2/3. Divide by 5. Or not 2/3, or not 2/5, 2/3, right? So I have 2/3 x like that. So it goes through 0, 0. It's like 2/3 x plus 0. And then from there we have a slope of 2/3. So up to right 3, up to right 3, up to right 3, and so on. You could also go down to left 3. That would work as well. Okay, our slope is positive in the end. And we know it's a solid line. So we draw on the line. So since this one goes through 0, 0, it is very tricky because now we can't plug in 0, 0. 0, 0 would work because it is less than or equal to, right? But we want to pick a point other than 0. Yeah, so what point?
No.
Well, 1, 1, it's still kind of hard to tell if it's on that point, right? So I would go up here somewhere. I'd say, okay, well, what if I try like 0, 5? Okay, so you can try a number that's way up there. Okay, and you can plug into your simplified version, which would be easier if you know that you did all of those steps correctly. Or you could plug it into the original. So usually to kind of be on the safe side, I usually kind of plug it into the original, just in case I left something off. So if I plug into the original and I try like 0, 5, or even 0, 1 would work. Do you guys see 0, 1? Let's pick that one because it's just slightly above. Then I have negative 6/5. I'm going to have 0, because 10 times 0, minus 15, and then plus 3. I want to see if that's less than or equal to 3. So I have negative 6 over 15 times negative 15 plus 3. So negative 6 over, sorry, I said 6 over 15 to 9. Negative 6 over 5 times negative 15 is going to be,
18.
yeah, these will make a negative 3. So negative 6 times negative 3 is 18. Plus 3 is less than or equal to 3. Is that true? No, that's false. So that tells us that we do not shade our 0, 0, or our 0, 1 or our 0, 5. We shade below the line. Now, did I have to do it that way? Okay, so who figured out that it was going to be below before I even did that? Okay, so what do you think, Cade?
If it's just less than, it's going to be...
Exactly. Remember that trick I told you? When it says less than, it's going to be below, as long as you have solved for y. As long as you have like y is less than, greater than, whatever, mx plus b. Okay, then when it says less than, just know it's going to be below. And then you don't have to do all that stuff. Doesn't it make it easier? The only thing that's tricky is you have to make sure that you remember to flip the sign, you know, like when you divide or multiply by negative, don't forget to flip the sign, okay? Because then that will mess it all up if you don't. All right, so this one. So it says the school carnival charges $5.50 for adults, $4 for children. The school needs to make at least $220 to cover expenses. Using X as the number of adult tickets and Y as the number of child tickets, write and graph an inequality for the amount the school needs to make on ticket sales. So X is our number of adult tickets. And for each of those tickets, I'm making $5.50, right? So we're going to do $5.50 times X. And then for each child ticket, we're making $4, right? So we're making $4 times Y, so 4Y. And it needs to be at least $220. So I'm not going to say equals 220. What sign am I going to use? Greater than. We want the amount we're bringing in to be greater than or equal to 220, right? So if we're graphing this inequality, it's a little bit tricky. I would do the x-intercept, y-intercept method. Okay, so you can get your calculator out. Somebody have their calculator out for me. All right, if I'm finding the x-intercept of this line, remember I'm plugging in 0 for the y. So I'm solving 5.50x equals 220. So take 220 and divide by 5.5. And then let me know what we get. 40. All right, so I have 40 comma 0. Now if I find the y-intercept, I'm plugging in 0 for the x, and I get 4y equals 220. So what do I get there? 55. Good. Look at you, Eric, without a calculator. So proud. All right, so when I'm graphing this, I'm going to have 40 comma 0. So let's go by 10s. 10, 20, 30, 40. And if I go by 10s for the y's, 10, 20, 30, 40, 50, 60, I'm going to go right between the 50 and the 60. And I have a solid line. Oops, missed it. And when I check 0, 0, I get 0 is greater than or equal to 220, which is not true. Now this should make sense that we're above this line, right? Because we want to make more than 220. So, you know, if we have a point that's way up here, like 100 child tickets and 100 adult tickets, that's good. We want to sell. We want to sell out, right? So it says if 25 tickets are sold, how many adult tickets must be sold to cover their expenses? So do I plug this in for X or do I plug it in for Y? Y, because Y was the number of child tickets, right? So I'm going to have 550 X plus 4 times 25. That has to be greater than or equal to 220. And you can kind of tell from your graph. So this is adults, and this is child tickets. If you go up to 25, you can kind of estimate where you think it is for the adult tickets. I think it's probably around 20 or 25, right? Based on my graph, but my graph was a little wobbly, so we'll see. So I get 550x plus 100 is greater than or equal to 220. Subtract 100. And then divide out by 550. So who's going to be my calculator person? What do we get when we do 120 divided by 5.5? 20 what? 818 something. It keeps going. All right, so how many tickets do we need to sell? 22. At least, right? It's all right, at least 22 tickets. Because 21 wouldn't quite cover it. All right, does that make sense? You guys understand that? All right, and the last thing we have are graphing things that aren't lines. So things that are, you know, absolute value or x squared or whatever. I think it's just absolute value on these ones. So it says graph the absolute value inequalities. When you graph these, it's just like linear inequalities. So first you decide if the boundary is solid or dotted. You graph the boundary line, and then you pick a point to see if you go above or below. All right, so I have y is greater than or equal to absolute value of x minus 2. So my boundary is y equals absolute value of x minus 2. So if you need to do a t-table on that, you can. When you have absolute values, it's good to pick like positives and negatives. So let's do -2, -1, 0, 1, and 2. So when you plug -2 into the absolute value, you get 2, minus 2, 0. -1 in the absolute value gives you 1, minus 2 is -1. 0 gives you -2. 1 gives you -1, and 2 gives you 0. So we have -2, 0, -1, -1, 0, -2, 1, -1, 2, 0. And we know that it's a solid line. And we basically decide if we're shading above the V shape or below the V shape. So your two possibilities can be inside or it could be outside, okay? What do you think this one's going to be? It's going to be like inside or above, right? And it's because of that y is greater than or equal to. You want your y values to be above that, okay? But you could check, if you check 0, 0, you would get 0 is greater than absolute value of 0 minus 2. So 0 is greater than or equal to -2, which is true. So that means we shade above. I'm going to extend this a little bit, actually. I kind of like to trap it on the grid. All right, so it's going to be like right here. All right, and same thing for the next one. So picking good points for your t-table is kind of key. What's the thing that makes inside that absolute value, like what can I plug in for x to make it as small as possible? 3. So put that in the middle of your t-table. So we're going to do 3 and then 2 and 1 above it, 4 and 5 below it. Because if you're trying, like, let's say we try -3. When you plug in -3, you get -3 minus 3, right? -6. So absolute value would be 6 plus 2. You're up really high, right? We want to be kind of close to the axis. You could do that, but. All right, so if I try -1, I get, or sorry, 1, I get 1 minus 3 is -2. Absolute value gives you 2. Plus 2 is, Next one, 2 minus 3 gives you -1. Absolute value gives you 1. Plus 2 is 3, exactly. 3 gives you 2. 4 gives you 1 plus 2, which is 3. And then 5 gives you 2 plus 2, which is 4. So plot this point. So I have 1, 4, 2, 3, 3, 2, 4, 3, 5, 4. So really the key is like you want it to go back up and create that V shape. So once you have it going back up, you're like, oh, okay, I got it now. I can see the shape. And it's a dotted line. Be careful. I bet a lot of you guys are going to go through and erase right now. So dotted. Did you guys ever do that in Algebra 1 where you're like, oh, no, and then you go erase, 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 erase? I feel like I always did that. All right, so, and then I decide if I'm above or below. So what's your guess on this one? It's below, yeah. So you can check 0, 0. If you check 0, 0, you get 0 is less than absolute value of -3 plus 2. So 0 is less than 5, which is true. So we shade towards 0, 0. So 0, 0 is included in our answer. That's it. Okay, so basically any point that we pick in the shaded area would make that inequality true. All right, was this okay? Okay.